Fairy lights are incomplete without the lights. So let's add some LEDs and toggle them. So the 𝗙𝗲𝗲 timer has two outputs, high and low. When the output is high, one of the LEDs should turn on, and when the output is low, the other one should glow. Let's see how the LEDs work with the help of the 𝗙𝗲𝗲 timer IC. Let's bring in an LED from the components library to the workspace. Shall we give the LED a different color? So click on the LED and select a yellow color from the drop-down menu. Great! Place our yellow LED on the breadboard. Now for the second LED. So off to the components library and take one more LED and place it on the workspace. Change its color to green and fix it on the breadboard near the first LED. What about connecting the LEDs then? But hey, we can't directly connect the LEDs. You see the big battery? That's the one powering up the entire circuit. If we directly connect the LEDs, they will explode. That's an immediate red flag, pal. So we need something to limit the current flow. Know any components appropriate for the job? That's right, we have the resistor. You can see the resistor on the components library. Bring it on to the workspace. Click on the resistor and you can see the resistance as 1 kilo ohm. That's pretty high. Let's reduce it. So change the unit to ohm and resistance to 500. So that's a 500 ohm resistor. Now to connect them, we have to understand some simple logic. The output from the 𝗙𝗲𝗲 timer should be given to the negative leg of one LED and the positive leg of the other LED, so that when the output is high, the LED whose positive leg is connected to the 𝗙𝗲𝗲 timer turns on, and when the output is low, the LED whose negative leg connected to the 𝗙𝗲𝗲 timer turns on. So take the resistor and connect it to the positive leg of the green LED. We have one more LED, right? So bring in another resistor from the components library and change its resistance to 500 ohm. Let's connect the resistor to the negative leg of the yellow LED. Hey, we are not finished yet. That's just the resistors. Now we have to provide output from the timer IC to the LEDs. So off to the wire section and take a green wire. Let's take the output from the out pin. You can easily find the out pin by simply placing the cursor on the pins. Yes, pin number 3 is the output pin. So with the green wire, connect the out pin to the other terminal of the resistor of the yellow LED. Now for our second LED. Take the connection from the out pin from here and connect it to the other terminal of the green LED. Did you know when Christmas trees were first lit up by fairy lights? Well, it was on December 22nd, 1882 by Edward H. Johnson. He was actually a colleague of Thomas Edison. Thanks to this, we can now decorate our Christmas trees beautifully, right? So we have given the output to the LEDs and it's time to power up the LEDs. Take a red wire and connect the positive leg of the yellow LED to the positive rail of the breadboard. But did you notice something? We have already connected the negative side to the out pin of the 𝗙𝗲𝗲 timer. When the output of the 𝗙𝗲𝗲 timer becomes low, the yellow LED lights up. So that's all about the yellow LED. Next up, yes, the green LED. Its positive is already connected. We just have to connect the negative leg. So take a black wire and connect the negative rail of the breadboard to the negative leg of the green LED. When the output of the 𝗙𝗲𝗲 timer becomes high, the green LEDs lights up. We have completed connecting both the LEDs. So we already know that the 𝗙𝗲𝗲 timer produces an output that switches between high and low. But to produce this output, we need to connect the trigger pin and the threshold pin together. Well, let's do that next. So take a purple wire from the wire section, connect pin number 2, which is the trigger pin, with pin number 6, which is the threshold pin. Adjust the wires a little and good. But you see, both the LEDs will receive output at the same time. To make the LED switch alternately, we should provide a time delay. For that, we will use a capacitor. A capacitor provides a time delay by charging and discharging. Let's connect a capacitor with a circuit to see how that works. So head over to the components library and bring in the capacitor to the breadboard. We are going to connect the capacitor to the input. This is because if we provide a delay at the input, then naturally a delay will be obtained in the output. So take a blue wire from the wire section and connect the threshold pin to one terminal of the capacitor. Then change the wire color to black and connect the other terminal of the capacitor to the negative rail at the top side of the breadboard. Adjust the wire a little and yes, perfect! So we did all the connections and this connection was for the discharging of the capacitor. Next we can do the connections for charging the capacitor.